do an upgrade to this. I made these as a really cheap or inexpensive fix to my problem, but I've ordered some stuff, so I'll be replacing that in a little bit better way. I think it'll make it more sellable, which is eventually what I intend to do with these things, is to build them and sell them. That is, of course, why I'm testing the different generators and alternators, so I can make a complete unit that can be sold all in one big chunk. I have had people talk about making the actual flux generators, and I have thought about that, but I'd rather do a bolt-on version, so I can just depending on what generator or alternator somebody intends to use with that, on whatever their needs may be, and just the turbine should be able just to bolt on to a generator, which that's my goal. Stainless steel, and that'll go all the way around the top and bottom of each of the turbines. Much stiffer than the other stuff, so this is good. That's $30.70 on that one. And that one's from Missouri Wind and Solar. I have probably 4 or 5 different electric places around here that have electric supply. None of them carry these, so I had to order them directly from Missouri Wind and Solar. It's another $6. These stainless steel. Another $88. This is going to be a high-grade repair, high-grade fix. So the idea here it went out. What I'll do with this is drill a hole right through the middle, well, close to the middle. I'll have to measure it out, because there will be 2 washers on one side. The other end is just going to be for a set screw, basically. So I'm going to drill a hole right through the middle of that, so that this wire will go through the middle. This is going to be screwed directly to the blade of the turbine. I'll drill a 1/4 inch hole in each turbine where the wire connects at this time, and a 1/4 inch hole, a bolt with a lock washer goes through the hole from the bottom, and then another lock washer goes, you have the blade in between the lock washers, and then the coupling nut That better be right. Okay, there we go. Now the coupling nut fastens firmly to the blade. The coupling nut will have a hole and goes clean through, and the wire goes through the hole. And then once all the wire goes all the way around to the turbine, through each of the holes that's on each blade, and then I do the fine adjustment, and then I take the other screw and it pinches against the stainless steel wire that's inside. And I think that's a prettier fix. It's a lot more solid. This will do more than just pull, so it didn't just pull tight, it also helps hold in either direction the wind may be pushing the blade, so it should be able to handle higher wind and a tougher generator. And what I mean by a tougher generator, I also ordered and received the Freedom II. Now, I've been very afraid that the turbines wouldn't have enough power to turn that, and that's why I was reluctant to buy it in the first place. And I'll share a bit of a story with you later. But that's what I'm going to try and fix up to the turbine next, and we will find out what it does. The difficulty in turning has been my biggest concern on whether I could run a Freedom II or not. So whether you can feel some resistance in the Freedom PMG, the first one, or the single, I guess. Can feel a little more resistance in this, but it's not a great deal. So could very well be that the turbine may not have much of a problem, at least until it's loaded. That really isn't all that difficult to turn. You do feel it, and it is. It is about twice as much as that, which is to be expected. You just have to play with it and see. Let's see how much power we can make.
You don't want to do that.
What? You said something?
Do you really think you can learn something that way? Have you ever had a wind that will spin your turbine at 600 RPM? Then use that brain of yours to find a more relevant way to do your testing. Oh man, you gotta watch this guy all the time.
PMG single, and we will start. Okay, we're running at 100 RPM on the Freedom PMG. Not very fast, is it? And we are not bad. Let's crank it up and see what it does when we go 150 RPM. So we're going to crank that up. 150 RPM. That's about the same as we were doing with the WindBlue. Well, that's much different than we were doing with WindBlue. We were doing 12 WindBlue. That's 27. Bad either. And we're running almost 4 amps. 3.4. Back over to volts. So there you go. You multiply your voltage here times your amperage, and that tells you the watts. So like I said, it's not loaded, so don't really know that part yet because I don't have a complete system to try it with yet. I'm just working on my wind turbines. First step. Okay, here's the big one. Now we are at between 90 and 100 RPM. And we're making 18, 19. Right in there. And the way we have this configured, oops, 120, 130, 140, 150 RPM. 150 RPM. Just kind of like that. And we are running 28, 29, 27. That's not bad. Not bad at all. For that speed, that's hard to beat. Now, we change the configuration a little bit, and we'll start it up again, and we're going to lower that back down to 100 RPM before we start the next test. 90, 100. Alright, turn it back. Okay, start it back up again. And we're in second configuration. So we are in series now. 100 RPM. That's in series. We're making around 40 volts. 40 volts. 100 RPM. So let's say we go ahead and move that up to 150 like we did the WindBlue. 120, 130, 140, 150 RPM. And I'm making some pretty good power right now. I like these a lot. It all depends on whether my turbine will actually turn it. That's a monster. Maybe we'll check on amps and see what the amps look like. This is amps. Ooh. That is tough on my Neil. Keep fluctuating between keeps losing RPM. Drawing a lot of power. Maybe a little bit hard on these wires too. Okay. We went back to voltage. It does tend to slow things down when you start checking the amps. It takes a lot more power. So with a load, that's going to be a tough one for my turbines to turn. Cool beans. Cool. Play with that pretty soon. I have 4 bolts on order, and hopefully I get those in another day or two, and I'll get to try that out. That'll be fun.
Who'd have thunk it?